In this given problem, a sequence Sn is given to you and we have to find limit superior of Sn. So first, limit of Sn as n tending to infinity, 1 plus 0 cos n pi. So this is the graph of cos function at multiple of pi. At multiple of pi, value is either 1 or minus 1. So limit of Sn for even multiple or even multiple value is positive 1 and odd multiple of pi value is minus 1. So finally we have 1 and minus 1. This is limit point or set of limit. Limit superior is supremum of this set means 1 and limit inferior is minus 1. Inferior is minus 1. According to this, we have option C. We have given a function fx and it is defined at 0 and from 0 to 1. You can check fx can be a split type function. We have to find value of integral this one. To find value of this one, what we have 0 to 1, 1 upon cube root of x dx. You can write 0 to 1 x raised to the power minus 1 upon 3 dx. Apply the formula x raised to the power n dx. We will have x raised to the power 2 upon 3 and take 3 upon 2 outside. Limit is from 0 to 1. After putting the lower and upper limit, we have 3 upon 2. 3 upon 2 is in option C, so option C is right one. In this given problem, W1 and W2 are two subspaces of vector space V. And V is finite dimensional vector space over field F. Dimension of W1 is 8 and dimension of W2 is 6. If W1 intersection W2 is non-zero, it means some elements contains intersection. If some non-zero elements contain in intersection, then this dimension of this intersection may be dimension of this intersection may be greater than 0 or surely greater than 0. Now recall the formula. Dimension of sum of W1 plus W2 equals to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. W1 dimension is 8 plus 6 minus the dimension of W1 intersection W2. As dimension of W1 is 8 and dimension of W2 is 6, so dimension of intersection will be at most 6. Also dimension is greater than 0, so possible dimension of intersection are 1, 2, 3, 4, 5 and 6. If we put in this dimension of intersection, what we have 14 minus 1. One by one we will put in this. 14 minus 1 is 13. 14 minus 2 is 2. 14 minus 3 is 11. 14 minus 4 is 10. 14 minus 5 is 9. And 14 minus 6 is 8. Now, so what we have? Dimension of W1 plus W2 will lies in 13 and 8. In 13 and 8. This is mean value and this is greatest value. Mean and greatest value represented by M and N. So this is M and this is N. So we have the value of M equals to 8, N equals to 13. So value of 3M minus N. 3M minus N equals to 3 into 8 minus 13, and this will equals to 24 minus 13. We have 11. So 11 in option C. C will be right key. A linear transformation phi defined from r raised to the power 4 to r cube be a linear transformation defining by this. We have to find nullity of phi. So there are two ways we can find nullity or rank. Using rank nullity theorem we can find other one. So this is image of an element. This is first constituents, this is second constituents, and this is third constituents. These three constituents make an image. So rank, what is rank? Rank is dimension of range of this linear transformation phi. What is rank? Rank is dimension of range of phi. What is nullity? Dimension of null space or null space of phi. What is rank nullity theorem? Rank plus nullity equals to dimension of domain vector space, vector space. In this given problem, domain vector space is R4 and dimension of R4 is 4. So rank plus nullity will be 4. This is direct from rank nullity theorem. So try to find rank of this transformation. Write the constituents in terms of matrix representation. So x1, x2, x3, x2, x1, x3, x4. Make other terms zeros or other entries 0. Using this matrix representation, you can easily see circular parts are pivot positions. So rank of this matrix is 3 and nullity will equals to 1. Nullity equals to 1 because 3 plus nullity equals to 4. So nullity equals to 1. Option B will be correct. In this given problem, matrix A is of the size 4 cross 4 over the field R and determinant of matrix A equals to 12. Phi denotes the Euler-Totten function or Euler function. Normally we say we have to find value of phi determinant of 6A. So what will be the value of this function? Recall the concept. If C is any scalar and A is a matrix, then determinant of scaled multiple of this matrix will equals to C raised to the power n into determinant of A when n is size of the matrix. So phi determinant 6A will equals to 6 raised to the power 4 into determinant of A and apply phi function. Now, according to structure of phi function, we have 6 raised to the power 4 into determinant of A is 12. Now apply phi function. So value of this one will be 6 raised to the power 4 into 12. You can write 2 square into 3. And what we have, this one equals to 6. You can write 2 raised to the power 4 into 3 raised to the power 4, 2 square into 3. Now combine all these powers of primes. So 2 raised to the power 6 into 3 raised to the power 5. So we have to calculate this one. So value of phi, this one, 2 raised to the power 6 into 3 raised to the power 5 will equals to 2 raised to the power 6 into 3 raised to the power 5, 1 minus 1 upon 2 into 1 minus 1 upon 3. We have 2 raised to the power 6 into 3 raised to the power 5 into 1 upon 2 into 2 upon 3. 2 cancel out by 2, 3, 1 power less. So 2 raised to the power 6 into 3 raised to the power 4. And this value equals to 5184. You can use calculator to evaluate this one. Option C will be right one. In this given problem, we have a system and this system has no solution. Then we have to find value of this one. First, write matrix representation for this system. So first row will be 3, 4, 7, 8, 2, 3, lambda 10, and third row is 1, 2, 4, 6. Now, interchange first and third row. We have equivalent matrix 1, 2, 4, 6. Second row same as 2, 3, lambda 10. Third row 3, 4, 7, 8. Apply elementary row operation to make a 0 under 1. 1, 2, 4, 6, 0, minus 1, lambda minus 8, minus 2, 0, minus 2, minus 5, minus 10. So this is our equivalent matrix. Now again apply elementary row operation to make this entry 0. We have first row as 1, 2, 4, 6. Second row 0, minus 1, lambda minus 8, minus 2, 0, 0, minus 2 lambda plus 11 and minus 6. So this is our coefficient matrix. This is coefficient matrix and complete is augmented matrix. For no solution, rank of coefficient matrix must not be same as rank of augmented matrix. So this entry should be 0. This entry should be 0. If this entry will be 0, then rank of augmented matrix have these non-zero rows, means rank of augmented matrix will be 3 and rank of coefficient matrix will be 2. And you can easily observe these two are not equal. It means minus 2 lambda plus 11 equals to 0. We have value of lambda equals to 11 upon 2. We have to find value of 4 lambda minus 8. This will equals to 4 into 11 upon 2 minus 8. 4 cancel out by 2 times. So 22 minus 8 equals to 14. Now match 14 is in option A. If the inverse matrix of A can be written in this form, then we have to find value of this one. This is I plus M plus N. So first try to find the characteristic polynomial for matrix A. You can expand 3 minus x, 4, 5, 4, 1 minus x, 0, minus 1, 2, 8 minus x. Find this matrix. This is coming from A minus xi. To evaluate characteristic polynomial, we expand this one. After expansion, we have 3 minus x, 3 minus x, 1 minus x, 8 minus x, bracket close, minus 4, 32 minus 4x, minus 10, minus 1, 0 minus 5, plus 5x. This is our characteristic polynomial. Now, after further simplifying, we have minus x cube plus 12 plus 12x square minus 24x minus 59 equals to 0. Now apply Cayley-Hamilton theorem. Every matrix satisfies its Kerr equation. So minus a cube plus 12a square minus 24a minus 59i, this is identity matrix, equals to 0 because of matrix satisfy its Kerr equation. Now on further simplifying, we have minus a square plus 12a minus 24i minus 59 a inverse. Because matrix inverse exists, so you can multiply by a inverse both sides. Now we have minus a square plus 12a minus 24i equals to 59a inverse. And it is given a inverse can be written as minus 1 upon 59 a square plus 12 upon 59 a minus 24 upon 59 I. So this is value of I, this is m, and this is n, and we have to add all these. So minus 1 upon 59 plus 12 upon 59 minus 24 upon 59. After simplifying this, we have minus 13 upon 59. So which one option is giving this? Minus 13 upon 59, option D will be correct. In this given problem, we have a linear transformation from R cube to R cube, and standard ordered basis is 1 0 0 0 1 0 and 0 0 1. Matrix representation of this linear transformation we have. Then we have to find image of 6 5 7. So matrix representation, so first column representing T 1 0 0, second column representing T of 0 1 0, and third column representing T of 0 0 1. Means we have output for basis element. In direct, we have output of basis elements. So what does it mean? 6 5 7. We have to find image of this. Write this element in linear combination of basis element. So 6 times 1 0 0 plus 5 times 0 1 0 and 7 times 0 0 1. Because we need image of this one, so apply T. Because T is a linear transformation, so it distribute like as you know better. So we have this. So 6 times image of first basis element is -1, 7, 4 plus 5 times image of second element. By matrix representation we can write easily 0, 3 minus 6 plus 7 times image of third element 2, 1, 5. Now add all these. After adding we have 8, 64, 29. It is matching from option B. So B is right key. An is defined as over my screen, and we have to find radius of convergence of power series summation an z raised to the power n. So radius of convergence denoted by r. R is 1 upon limit n tending to infinity un raised to the power 1 upon n. Un, or you can say an. An is split into two terms, so you can find r1 and r2. So 1 upon limit n tending to 0, first for n equals to 0, 2 raised to the power 1 upon n. As n tending to 0, 1 upon 2 raised to the power 0, and this is equals to 1. R2 equals to 1 upon limit n tending to 0. An is 2 raised to the power n and 1 upon n. So this one will go to 1 upon limit n tending to 0, 2. This is constant, so 1 upon 2. Radius of convergence r will be mean value of r1 comma r2. Why mean value? Because some series is convergent for this reason, and this series is convergent for this one also. So mean value, suppose larger one is r1 and second two is r2. So shaded region will give you exact convergence of the series. So we take mean value of r1 and r2. So mean value is half. So option B is correct. If phi is the Euler-Toten function, and if value of phi 12 raised to the power 4 into 15 raised to the power 3 is this, then we have to find sum of alpha, beta and gamma. So phi of 12 raised to the power 4 into 15 raised to the power 3 can be written as phi of 4 raised to the power 3 into 3 raised to the power 4 raised to the power 4 into 3 raised to the power 4 into 3 raised to the power 3 into 5 raised to the power 3. So combine these two. Now you can write 4 raised to the power 4 means 2 raised to the power 2. So 2 raised to the power 8 into 3 raised to the power 7 into 5 raised to the power 3. And value of this one will be 2 raised to the power 8 into 3 raised to the power 7 into 5 raised to the power 3. 1 minus 1 upon 2, 1 minus 1 upon 3, 1 minus 1 upon 5. We have 2 raised to the power 8 into 3 raised to the power 7 into 5 cube into 1 upon 2 into 2 upon 3 into 4 upon 5. 2 cancel out by 2, 3, 1 power less, and 5, 1 power less. So what we have, and this 4 you can write 2 raised to the power 2. So finally we have 2 raised to the power 10 into 3 raised to the power 6 into 5 square. So this is the value of alpha, beta and gamma. Alpha plus beta plus gamma equals to 10 plus 6 plus 2 means 18. Option C is correct. In the symmetric group S8, we have to find product of 1, 4, 6, 8 composition, 3, 4, 2, 1, 6 composition, 4, 8, 6, 3 inverse. So inverse of this element or permutation is just reverse the element. 3, 6, 8, 4. This is inverse. Or if you write matrix, so just reverse the image of input and write other cycles as same as or other permutation. 3, 4, 2, 1, 6. We have to find composition of this one. So pick last one. Pick 3 from last one. 3 is going to 6. 6 is going to 3 from this one, and 3 is going to 3. So we have 3 is going to 3. Cycle closed. Now again pick 6. 6 is going to 8. In second permutation, 8 is going to 8, and in first, 8 is going to 1. So 6 is going to 1. Now pick third element. Sorry. Now 1. 1 from third one. 1 is going to 1. 1 is going to 6 in second one, and 6 is going to 8 in first one. So 1 is going to 8. Now check 8. Now 8 is going to 4. 4 is going to 2. 2 is going to 2. 8 is going to 2. Now check 2. In third one, 2 is going to 2. In second one, 2 is going to 1, and 1 is going to 4. So 2 is going to 4. So there is no need to write this one. 6, 1, 8, 2, 4. 6, 1, 8, 2, 4. Because of 3 is cycle. 3 is independent cycle or only having one element. So option C, 3 is going to 2, and in option B, 3 is going to 2. So B and C are discarded. 6 is going to 1, 1 is going to 8, 8 is going to 2, 2 is going to 4. You can write this one as 1, 8, 2, 4, 6 and cycle closed. In option A, this is matching. It will be the right key. The Wronskian of the function e raised to the power at sin bt and e raised to the power at cos bt. We have to evaluate. So how to evaluate? Evaluate e raised to the power at sin bt, and the second function is e raised to the power at cos bt. Take derivative of these two. So derivative of first one will be b e raised to the power at cos bt plus a sin bt e raised to the power at. And derivative of second one will be minus b e raised to the power at sin bt plus a cos bt e raised to the power at. Wronskian will be expansion of this determinant. This is function, first function, so you can call ft, and this is gt, and the second row means f prime t and g prime t. So after expansion means multiply crossly, we have minus b e raised to the power 2at sin square bt plus a e raised to the power 2t cos bt sin bt minus b e raised to the power 2at cos square bt minus a e raised to the power 2t cos bt into sin bt. You can observe this term will cancel out by this one, and you can take common from these two. So common is minus b e raised to the power 2at, and this will be sin square bt plus cos square bt. By the trigonometric identity, it will be 1. So we have minus b e raised to the power 2at. As you can see, option C will be right one. In this given problem, we have initial value problem, and we have to find solution of this one. Write auxiliary equation in terms of m. So m square plus 2m plus 4 equals to 0. Find roots of this by quadratic formula. So minus k2, so minus 2 plus minus under root b square minus 4ac divided by 2. This implies minus 2 plus minus 12, or you can write 12 iota square divided by 2. This one is equals to minus 2 plus minus 2 root 3 iota upon 2, and after further simplifying, we have minus 1 plus minus under root 3 iota. So complementary function yt, because t is independent variable, will equals to e raised to the power minus t bracket a cos under root 3t plus b sine under root 3t. Apply initial condition y0 equals to 1. We have a equals to 1. After substituting t equals to 0 in this equation 1, we will get a equals to 1. Now use other condition to find value of b, as yt was e raised to the power minus t a cos under root 3t plus b sine under root 3t, and value of a is 1. Value of a is 1. Find y prime t. Y prime t will equals to minus of e raised to the power minus t cos root 3t plus b sine root 3t bracket close plus a raised to the power minus t minus a root 3 sine root 3t plus b root 3 cos root 3t. Now apply second initial condition y prime at 0 equals to 1. We have 1 equals to minus 1, 1 plus 0 plus 1 b root 3 this one equals to minus 1 plus b root 3. We have 2 upon root 3 equals to b. Now put this value of a and b in complementary function. So yt equals to e raised to the power minus t cos root 3t plus 2 upon root 3 sine root 3t. This is your exact answer. According to this, we have option B. Option B is right one.